Hi, welcome to the Calculus 1 lecture series. This is the second video for the Chapter 2 practice test. This practice test is the review of the unit we finished, is the limits and the derivative units. And for the first video, we covered the first two problems, and hope that this video will be able to cover all the remaining 6 problems here. All right, let's go ahead and start. Let's go to our practice test worksheets here. Okay, so let's see here. Okay. All right, so here we go. So last time for our first video, we stopped at when we finished the problem number 2, we, kind of refresh our memory, review what we did for the limits here. All right, so now let's go ahead and start here. Okay, so now we have a piecewise function. The f of x equal to this square root of negative x, 3 minus x, x minus 3. Evaluate each limit if it exists here, right? So the first thing is here, we say the limit when the x approach to 0 from the right-hand side, f of x, from the right-hand side, that means it's greater than 0. So which function I'm using here? I need to use this one, right? Because this is greater than, so I need to use this function. So when the x equal to 0, what is here? This is 3. Okay, so now the second one here is limit x approach to 0 from the left-hand side of f of x. So if from the left-hand side, see here, that means it's less than. So which function I'm going to use here is here, right? So it's negative x. So when you put the negative x to the square roots, so for the 0, what is here is zeros, right? Then the last thing is they want to find the limit x approach to 0. So we know in order for limit to exist, I don't know how many times we say the limit to the right-hand side have to be equal to limit to the what? To the left-hand side. And unfortunately, this one is not equal to. So what is here? So I know the limit x approach to 0, f of x is here. So what? Do not exist, right? Okay, so let's take a look here. The limit, okay, let's take a look at this one. Limit x approach to 3 from the left-hand side. Okay, so limit x approach to 3 from the left-hand side, right? So that means it's less than 3. So where is less than 3? Here, right? So it's less than 3. So I use this ones here. So when you put the 3 there, what do you got here? You got 0. So the same way, let's take a look. The next one here is the limit x approach to 3 from the right-hand side. Okay, so from the right-hand side here, that means what? X is greater than 0, right? So here, this is greater than 0. And then you say, oh, good. So what is 3 minus 3? So it's equal to 0. Then the last questions, they ask you, what is the limit x approach to 3, f of x? Then you say, because the right-hand side equal to the left-hand side, so what is the limit here? Limit is 0 here, all right? Then the next thing here, they said, where is f is discontinuous? Remember, right? So the discontinuous, let me get rid of all these color things. Right, so the discontinuous always happen where? At those jumping points, right? So at those jumping points. So the first ones here, I already know. Okay, so part B is here, right? So I already know x equal to 0. This is a discontinuous. Why? Because the limit not even exist, right? So f of x, this is do not exist. That is do not exist here. So remember we said continuity is one level higher than the limit. right? So if the limit have to exist, function value has to exist. And so for these ones here, limit is not even exist, so I know it's a discontinuous point. Then the next ones here is discontinuous at equal to 3. Why this one is discontinuous here? It's because, even the limit exists, but f of the 3, did you see an equal sign in here? No. That means what? F of 3 is what? Not even exist. Okay, so we say continuity is the higher level for the limits. So the limit has to exist. So for x equal to 3, limit exists. This is okay. But f3, the function value not even exist. Exist is not the only one. Have to be equal to the limit value. But for this problems here, the function value is not even exist. So we know this is discontinuous here. Okay, so this is another type of the problem. We'll kind of try to refresh, refresh our memories about what is the limits here, right? Okay, so now the next ones here, we're going to take a look at use the intermediate value series here. So everybody still remember what is the intermediate value series here, right? So these ones here, we talked before, we say, let's try to do a quick reviews here. Let me put it here. I can have a review here. Right, so we say it's just like, right? So we say if this is A, this is B, right? So we said really it's a pretty simple definition we say here, right? So if this is your f of x, if f of x, so what is the, so the intermediate value series, so the first things here, we say the f of x has to be what? Has to be continuous, right? And then the f of A, f of the B. So that means if you still remember, I would say, hey, if you find any number between n, then you can find at least one number C such that they have the same values here. So that means in here, you said if this one has to exist, then you have a number is between f of the A and between f of the B. Then you will find at least, right? So you can have more than one, at least one C such that f of the C equal to the nth here, okay? So now in here, we say, okay, now let's try the intermediate value to see there's roots. Let's try to review also, and we still remember what's the roots means? Roots, what does roots mean? That means this C values here has to be what? Equal to what? Equal to zeros, right? So we know the roots, the roots is the place like your function touched the x-axis here, right? So now that means if I want to use intermediate value theory, so one has to be positive, one has to be negative. It's kind of common sense because one has to be positive, one has to be negative. Then they have to pass in the zero in order to get from the negative value to the positive value or positive value to the negative values, right? Okay, so now let's say we let this one is my f of x here. So from the interval, so I say f of 1. What is f of 1? I put the 1 in here, so it's 1 minus 1 plus 3 minus 5. So what is this values here? This value, this is negative 2, right? And then I have f of the 2. So that means 2 to the 5th power minus 2 to the 3 power plus 2 times 3 times 2 minus 5, right? So 32 minus 8 plus 6 minus 5, I got a 25. So one is positive, one is negative. F of x, this is a polynomial. And I know the polynomial is what? a polynomial is continuous. Because this is a polynomial, it's a continuous. So I have the continuous condition, one is negative, one is positive. So based on the intermediate value, theory applies, right? Okay, that means at least, okay, one root C exists between what? 1 and 2, right? That means the f of the c has to be equal to 0. So the root exists. All right, so now let's take a look at the next ones here. So this is a cosine square roots of the x equal to the ex minus 2. What I can do is I can change these ones to the cosine square roots of the x minus ex plus 2 equal to 0. Okay, so now I can say this is my f of x. Let's say the roots exist or not, all right? So the same things here. So I said f of 0. F of 0 is a cosine 0 minus e0 plus 2. Cosine 0 is 1 minus 1 plus 2. All right, so this is 2 here. Okay, so now I have 1, so f of the 1 is a cosine 1 minus e plus 2. So you put a 1 into the, like the radian into your calculator. This one give you negative 0.1779, all right? So now you know there's one positive, one negative here. Now is f of x is continuous? Yes. Why? Because this is a combination of several continuous functions. Because the trig is continuous, right? And we know exponential is continuous. Right, so when you try to combine it, it is a continuous. So I know intermediate value theory applies. So at least, right, at least one root exists, right? So between 0, 1, such that f of c equal to 0. So that's what is the intermediate value theory. So make sure we do understand the conditions, right? So it's like a, there has to be continuous, and the one side is positive, one side is negative, right? Okay, so now, okay, we gradually get into the differentiabilities here. Okay, so the differentiability, so it's not differentiable. So we know the differentiability is what? Is the, is one higher than the continuity. So differentiability has to be continuous. And also the continuous is not only to be continuous, also what? I cannot have a sharp point, I cannot have the vertical line, vertical tangent lines, right? Those things, right? Okay, so let's take a look to see here. Oh, this one, this is a discontinuity. So this is x equal to 4, negative 4. This is not differentiable. Why? It's discontinuous. We said differentiability has to be one level higher. So this one is discontinuous. This is a discontinuous, right? So it's not a continuous. So of course, it's not differentiable. That's the reason. What is the next one here? Whoa, I see this one, right? So x equal to negative 1. Why is this one is not? Because even this is a continuous, right? So what is here? I have a sharp point. Or you can say you have a corner layer, so it's not differentiable. Oh, this one, I find this one, x equal to 2, this is not continuous. Why? Because I have asymptotes, right? So this is not continuous. If it's not a continuous, then definitely it's not differentiable. Then the next one here says x equal to 5 is here. X equal to 5 is here. The reason why, because the x equal to 5, if you find a tangent line, so what happens here? This is the vertical tangent line. So remember the vertical tangent line slope is what? Slope is do not exist, right? Do not exist. So if slope, we also know the slope is the what? The derivative of the function. So if slope is not exist, that means the derivative is not exist. That means it's not differentiable. All right. Okay. So now let's take a look at the next ones here. So they said, find the equation of the tangent line. Okay. Find the equation of the tangent line to the curve given below at the point x coordinate is 0 and the x coordinate is what? Is -1 here. All right, so the x coordinate is 0 here. Let's try the 0 first, right? So x equal to 0. So when the x equal to 0, so what is f of 0? F of 0 is 2 over 1, so it's 2. So I have 0 and 2. This is the point, right? So this is the point I'm supposed to go through here. Okay, so now let's try to find the slope. Okay, so we know the slope of the tangent lines here. So we said f of a is any number f of a here, right? So this is 2 to the 1 minus 3a. So when the x equal to 0, my a is 0. So I need to just find the general forms here. So this is f of the a plus h. Okay, so f of the a plus h here. So let's take a look here. We did this in our lecture notes several times. So that means 3, the a plus h, correct? Okay, so now let's use your algebra. So this is 2, this is 1 minus 3a minus 3h, correct? Okay, so now using the, so this is step number 1, right? So the step number 2, we say is f of a plus h minus f of a and over what? Over h here. Okay, so this is testing your algebra. So this is 2. This is 1 minus 3a minus 3h minus 2, 1 minus 3a. Okay, what do we need to do? Common denominators, right? So the common denominator, both of them have a 2. I can take the 2 out to save some heartburn here. Okay, so this is the common denominator is 1 minus 3a minus 3h and 1 minus 3a. So the first term will give you what? First term you will have 1 minus 3a. Then the second term is what? So you have a minus minus 1 minus 3a minus 3h. Okay, so like I said, you know, as long as you be very careful about your algebra, you'll be fine here. Okay, so here now you will have h. Okay, so this is the 2. So let me try to simplify over here. So this is 1 minus 3a minus 1 plus 3a plus 3h, correct? Okay, so plus 3a plus 3h is here. So now let's take a look. Okay, 3a, good. -1, +1. Oh, that's very good. So I have 3h inside times 2. So this is 3h. And I have what? I have, okay, so I need to be careful here. Don't want to forget my common denominator. Okay, don't want to forget my common denominator. So this is 1 minus 3a minus 3h, and 1 minus 3a. So what is here? 6h. All right, and now I simplify this. So this is 6h, 1 minus 3a minus 3h, and 1 minus 3a times 1 over h. All right, almost there. Okay, so whoa, h is good. We cancel that out, right? So that's good. Okay, so the step number 3. Now what I need to do, I need to find the limits, right? So I will say the limit h approach to 0 for this number here. So this is 6. 1 minus 3a minus 3h. 1 minus 3a. Okay, so now in here, the h approach to 0, that means this term will be equal to 0, right? So what is my final here? So this will be 6, 1 minus 3a to the square. Okay, so this is my what? This is my slope, right? So when the x equal to 0, right? So we said that when x equal to 0, then f of the 0, we just did it here. F of 0 is 2, right? F of 0 is 2. Okay, so f of 0 is 2. So I have, this is my point, 0, 2. So what is my slope here? When a equal to 0, that means in here, the slope here, it will be 6, 1 minus 3 times 0 to the squares, right? So be careful here, right? So this is what? This is my what? This is my a's, right? So here, this is my a. So the 6 times, so what is here? This is 6. So you have, okay, you have a point, you have a slope. So what is the algebra tell you? How do I find the tangent line at this point? Use the slope and 1 point, right? So that means y minus 2 is equal to the 6x minus what? 6 minus 0. So what is here? Y equal to the 6x plus 2. Okay, let's try again when the x equal to 1. So when the x equal to 1, now what is my f of 1 here? F of 1 is 2, 1 minus 3, right? So this will be negative 1. Okay, now let's do the slope again. So it's 6, 1 minus 3 times 1, the whole thing square. So this is 6 over 4. So this is 3/2. This is the slope. So now in here, the same one, I have what? I have a 1 point and I have a slope. So what can I do? I can use the slope and 1 point to find my lines here. So what is the slope and the 1 point here? So this will be y minus y1. So y plus 1 equal to the 3/2 x minus 1. Correct? So if you want to simplify, you can simplify that. That will be the tangent lines here. Okay, let's take a look. So what is the function f has a number such that? Okay, so these ones here, we say f prime a. So what is the, the f function and what is the number a here? Okay, so remember we said limit h approach to 0. This is our definitions, right? So this is a plus h minus f of the a to the h. So compare to the definition, right? So compare to the definition. So this is a plus h, right? So a plus h. So what is the a here? This is a plus h. So immediately I will know what? I will know the a is equal to what? A is equal to 2. Then here I have the 6 here. Then what is 64? 64 is what? 2 to the what? 6 powers, right? So what is my f of functions here? So my f of x is equal to the x to the what? 6 powers here. Okay? Right, so this type of problem is pretty simple, but it's a good problem to test your understanding about the concept. Okay, now the last one is here. So we said, what value of A does the limit exist? So you still remember what is this function? We called this is the greatest what? The greatest integer function. What is the greatest integer function? That means these functions always will give you what? Will give you a whole numbers here. So let's take a look, all right? So let's take a look here. So if I have x equal to 2.5, what is means the 2.5, the greatest integer function? That means it has to return a largest whole number less than this number. So what is the largest whole number less than this number? It's 2. Correct? So now this is a, how about if I said x equal to 2.5? Now what happens if I put a negative signs here? Negative sign, so it's a negative 2.5. So what is the greatest number less than negative 2.5? It's negative 3. So when you add these two together, so that means like x plus negative x, what happened here would be -1 because 1 is always like that because negatively drop to the next value. Okay, so now let's take a look at the other one. So if I have a 1, it's like a 2.0012. All right. So what happened to the 2.0012? So what is this number? What is the largest number? Is less than this one? It's 2, right? Now, if I put the negative here, so this is the negative 2.0012. So what is negative 0.12? What is the largest number? Is less than this number? It's less than 3. So as you can see, if you add these two together, what is here? Still is -1. So I got the idea, right? So we said, looks like you give any number, they always have a limit equal to -1 here. How about let's take a look. If x equal to 3, whole number. So the whole numbers here, if you put a 3 in the whole number, what is this one? Was equal to 3. Okay, so when you put the x equal to, okay, so now you put the negatives here. Okay, so if you put the negative numbers here, right? So you put it like the -3, what is still going to be -3. So now you know the x plus the negative x is always going to be what? Going to be 0. Okay, so I know, right? So that means all the number they're going to add up to the -1, except add the what? Add the whole number. So I know this is what going to be my function. Looks like this is 1, 2, 3, 4, 1, 2, 3. So my function going to be like this. If it's a whole number, it's going to be like this, 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 going to like this, right? And then all the number in between, so 0 is going to be here. So this is like this. So basically, this is what, what is my function looks like. So now we be able to answer our questions here. The first question is, what value limit exists? What is the limit, what is the limit exists here? What is that? So the limit exists, what? Of course, all these points exist, right? All these points exist. So we know limit exists for all the real number. So they're not continuous because when they reach the real number, they're going to boom, jump to zero, boom, jump to zero, right? So it's all the real number. So, but where the discontinuities here is the all whole numbers, right? While ago I said, it's not a continuous, the whole numbers, right? So this is all whole numbers. That what is the graph, because like here, this is the graph here. So when you approach here, right, from the right hand side, from the left hand side, and then they're going to all approach to -1, except when they become it, then your function going to jump to over here. So it's a discontinuous. So where is discontinuous at all the whole number, but the limit exists for all the real numbers here. All right. That's it. And this is a very good problem here. Is also, test your understanding about the limit concept. All right. All right. That's it. And hope that this brief practice test give you a good review about this unit's concept. All right. That's it. Have a nice day, and looking forward to start our next unit here. All right. Bye. Have a good day. Bye-bye.